Okay, we're going to do a problem here. And get my pen to work. This is going to be number 64 on page 116. This is called Attwood's machine. It's a classic physics problem. It's a net force problem using Newton's second law. And we have three objects here, but we're going to just count the two objects on the right as one big object, which would be 7 kilograms, all right? Excuse me. So basically what we're going to do is we're going to do two force diagrams. We're going to do a force diagram for each object. The first one is the 5 kilogram object on the left-hand side. So that's 5 kilograms. If we use 10 for G, then we have 50 newtons pointing downward. And we have a tension force upward. We do not know the tension force. And then we have one big object on the other side that's going to be 7 kilograms total, and there's also a tension force upward in it, and 70 newtons down this way. Well, when you let go, you can already tell that the 7 kilograms is going to go down in the negative direction. The 5 kilogram object is going to go up in the positive direction. That means that the tension on the left-hand side must be bigger than 50 newtons. The tension, which is equal to this tension, both tensions are equal. It would have to be smaller than 7. Now, the tensions are only equal if this pulley is frictionless and is massless, meaning it doesn't have any moment of inertia. We'll study that in another chapter, so we're going to make it kind of easy. Well, we want to know the acceleration of the 7 kilogram object, which is going to be pointing down. And we want to know the acceleration of the 5 kilogram object, which will be pointing up. Both of these will be equal also. So we're going to make an equation. Now, we're going to start with the 5 kilogram object, and it's going to be T, up is going to be positive, down negative, so T minus 50 newtons equals 5 kilograms times A. So notice I have two unknowns here, and some of y'all wondered how I got that equation. Well, it's the sum of the forces equals MA. Sum of the forces meaning I'm summing up these two forces. In this case, I subtract because they're opposite directions. And that equals M times A. It always equals M times A. Net force always equals M times A. In every chapter, always. So I have to have another equation. Well, we get the other equation over here from the 7. And so I'm going to say tension minus 70 newtons equals 7 kilograms times negative A. Why negative? Because that acceleration is in the negative direction. What I'm going to do here, and I'll do this in a different color, is I'm going to subtract these from each other. Meaning I'm going to multiply through by negative, make everything positive, and then I'm going to just add them together. Well, T minus T is 0, and then I'm going to have 70 minus 50, right? Because and that's going to give me a positive 20 newtons. And I'm going to add these two because everything's positive now. So I can do 7 plus 5, which is 12 kilograms times A. Well, now I only have one unknown. Divide both sides by 12 kilograms, and 20 divided by 12 is going to be 1.66. And if you look in the problem, we had 1, 2, 3. We had 3 significant figures, so we'll just say 1.67 meters per second squared. That is the acceleration, all right? And they want also the tension in the two strings. Well, the tension's equal. The tension's equal. So let me extend this page just a little bit here. I think this will work. The tension, all I have to do is go back to one of my original equations. I'll just go to this one, and I'll just substitute back in this 1.67 into that equation. And if I do that, I'm going to get tension minus 50 newtons equals 5 kilograms times 1.67 meters per second squared. And if I do 5 times 1.67, I get 8.33. So basically I have t minus 50 equals 8.33. Well, if I just add that to both sides now, I get 58.33. So tension in either cable, doesn't matter, is going to be 58.3 meters. 3 significant figures. That's how you do one like that, and they're done the same no matter what these two objects are. You're going to set up two diagrams, and from those diagrams you're going to use Newton's second law to get two equations, and then somehow using systems of equations you're going to solve for one of the unknowns.